Okay, welcome America, India, and Selena Gomez. I know it's been a bit since we've recorded, but today we are going to do two problems, one on polynomial inequality and a rational inequality. So let's go ahead and start. I've already started this one a little bit, problem number 8 on the worksheet, which I hope to attach. So first things, we've got to get everything to the same side and take a look and see what we have. In this case, I distributed the x, moved the 20 over, and now I've got x squared plus x minus 20 is greater than 0. So I went ahead and factored that, and I know that my zeros are at 5. Did I mess that up on my graph? I did. 5 and negative 4. Okay, it's fine. And when you draw them on your number line, you gotta make sure you put, since it's a number line, the lowest number first, highest number. So we gotta have a 5 and a negative 4. So this has to be negative 4. And this has to be a positive 5. It's fine, whatever. All right, they're asking, where is this graph greater than 0? We can see that here's negative 4 and here's 5. And they're asking in terms of x. The graph is greater than 0. Above the x-axis up here. Where's the graph above the x-axis? From negative infinity to negative 4, it's above the x-axis. Then it goes below. And then it's above the x-axis again from 5 to infinity. So how we do that without the graph is we draw ourselves a number line. There we go. And again, the negative value goes over here, negative 4, positive value goes here. So without having the graph, we plug in a value that's lower than negative 4, like negative 5, for example. Negative 5 minus 5 is going to give us, it doesn't matter what the value is, we just have to know the sign of the value. Negative 5 minus 5 is going to give us a negative value. So this is going to be a negative. And then negative 5 times 4 is going to give us also a negative value. So a negative times a negative is going to give us a positive. All these values should be above the x-axis. And you can see, confirm that by looking at the graph here. Now let's put in a value between negative 4 and 5. Looking at the graph, this value should end up being negative. So let's just put in 0. It's a nice number to put in. 0 times negative 5 is going to be a negative. 0 plus 4 is going to be a positive. Negative times a positive is going to be a negative. Confirmed by the graph. Last one. 6. I'll put a 6 in because 6 is above 5. 6 minus 5 is going to give us a positive value. 6 plus 4 is going to also give us a positive value. Positive times a positive is a positive. So where is the graph greater than 0? It's here and here. So we're going to write the interval. And it's not greater than or equal to 0. So we're not going to include these values. So we're going to say it's from negative infinity to negative 4, but not including negative 4. Union with 5 to infinity. If this problem had said, where is the graph greater than or equal to 0 in a different color, red, equal to 0, the only way this would change is we would include these values with a hard bracket. Any questions? We're going to move on to problem number 11. Are we still writing? Are we still writing? Okay. No, not number 11. What number did I say?
12.
Thank you. I already have 11 recorded. All right, so number 12, we take a look. We've got a 0 at 2, right? And we've got vertical asymptotes at 1 and negative 1. So without looking at our graph, we're going to draw ourselves a number line, and we're going to have important values. At negative 1 is going to go first on the number line. Then we're going to have a 1 and also a 2. Now remember, this is an asymptote. This is an asymptote. and that's 0. This is asking where is the graph greater than or equal to 0. So let's go ahead and start. We're going to have 4 intervals. So we're going to have to figure out plus, minus, which are which. Go through each of them. So -2. -2 minus -2 is going to be a -4, but that's going to be squared. That's going to be a positive value in the numerator. And then, what did I put in? -2. -2 squared is going to be a +4. -1 is still going to be positive. So that should be positive. Checking my work as I go along. Good. 0. I'll put a 0 in because 0 is between -1 and 1. If I put a 0 here, I'm going to get a negative value. It's going to be squared. That will be positive. If I put a 0 here, I'm going to get 0 minus 1. That's going to be a negative. Positive divided by a negative is going to be negative. Between 1 and 2, we're going to have to pick maybe 1.5. 1.5 minus 2 is going to give me a negative value, but then I squared, it's going to be positive. 1.5 squared is going to give me a nice value that's going to be above 1, and I subtract 1, I'll end up getting a positive value. Right? Yeah. Okay, so that should be positive. Yep, confirmed. And same thing should happen for above 2. So put 3 minus 2 squared is going to be positive, and then 3, that's going to be positive. That should be positive. Now, it's asking, where is the graph greater than or equal to 0? Okay? It's greater than or equal to 0 from -infinity up to -1, but not including -1 because that's an asymptote. Everybody okay with that? We're not including the -1 because that's an asymptote. So it's not on our graph, no matter what. Union with. Now we've got 2 intervals here, but this is asking where is the graph greater than or equal to 0. So we're going to include that 2 because that 2 is not an asymptote. It's a 0. So we can go from 1, including the 2, all the way to infinity. But we're not going to include this 1 because it's an asymptote. So that's going to go from 1 to infinity. Yeah. Any questions? Okay, if this problem had said, where is the graph greater than 0, not greater than or equal to 0? It's kind of a fine line because you'll talk about this in calculus. We don't really want to include this value, so we might have to give this interval and then this interval and that interval and not including the 2. That's it. Peace out.